Assalamualaikum and hi everyone. My name is Muhammad HILMI bin ABDUL and my metric number is A174596. Today we are from group 7 going to represent our mini project which is switch reluctance motor. For introduction, SRM, which is switch reluctance motor, has attracted much attention in industrial application, including wind energy system and electric automobiles. The switch reluctance motor is an electric motor with a moving element that generates torque and moves to a location where the exciting winding inductance is maximized. We can see the diagram of switch reluctance motor in the slide. Next, for the problem statement, SRM has a very high torque ripple component which is due to the transition of the current from one phase to the following one. This torque ripple is particular characteristic of the SRM and it depends mainly on the converter turn on and turn off angles. Other than that, the number of phases of the SRM also can affect the ripple. For the objective, firstly, to study the behavior of SRM switch reluctance motor in open loop control. Second, to check the effect of the number of switch reluctance motor phases on the ripple torque. And lastly, to study the effect of the turn on and turn off angle on the ripple torque. Next, we are going to explain the simulation of switch reluctance motor. We are using MATLAB software for the simulation. The methodology part. First, the MATLAB online was opened. Second, the code power underscore switch reluctance motor was typed in the MATLAB window and enter was pressed. Third, the figure below appeared, which showed the switch reluctance motor for 3, 4, and 5 phases. Fourth, the simulation was run. Then, the scope for each phase was observed. Fifth, the wave for each circuit were compared in this discussion.
Hi, my name is ARINAH BINTI FADZIL and my matrix number is A174718.
The slide showed the torque ripple result for 3 phase of switch reluctance motor. Next is for 4 phase of switch reluctance motor. And the last one showed the ripple torque for 5 phase of switch reluctance motor. The table shown the maximum torque when the turn on and turn off angle change for every phase. So for the discussion, first, torque ripple refer to a periodic rise or reduction in output torque when the motor shaft spins, evident in many electric motor design. The sequential switching of the motor phases and changes in the length of the air gap is the switch reluctant device exhibit torque as well. When one of these coil magnet is rotated, the rotor whips violently over the simulation. The pulse of the magnet causes a torque pulse. Next, we suggest a torque ripple reduction method by increasing the number of phases in this project. As seen from the wave obtained in phases 3, 4, and 5, the ripple torque reduces as the number of phases increases. The ratio of excitation increases as the number of phases increase. It adds to a boost in minimum and average torque. A rise in the excitation ratio, on the other hand, generates an increase in the input power, the magnetic motive force per phase. On the other hand, decreases as the number of phases increases. It aids in the reduction of maximum and average torque. The number of phases and segment cores combine to determine the excitation current waveform of the segment type SRM. The torque waveform can be improved by changing the number of phases and cores and exciting 2 or more phase winding at the start and end of excitation. The SRM system's control action aims to provide speed and torque management by optimizing 6 parameters, including the proportional and integral gain speed controller and the turn on and turn off angle. We also emphasize that turn on and turn off angle can affect the torque ripple of SRM. SRM generates only an electromagnetic torque which depends on the excitation angle according to rotor position.
Assalamualaikum. Hi, my name is ATIQAH binti NAZIROM. My matrix number A1744723. Now I will explain our conclusion part. From this project and simulation, we learn about the behavior of switch reluctance motor and how to reduce the torque ripple. For example, we can increase the number of winding in the stator or the number of pole in the rotor. Torque ripple minimization is a relatively new technique that aims to smooth torque over extensive speed range. Although the torque ripple will rise as the speed increases, this technique are ideal for application where the speed range is wide. Also, the proposed method uses fuzzy logic control to reduce periodic speed ripples in switching reluctance motor. Using fuzzy logic control in MATLAB or Simulink, it is easier to control and minimize periodic speed ripples. The above simulation results indicate an accelerated reduction in torque and speed when implementing the fuzzy controller for switching reluctance motor. The SRM with less torque ripple will almost surely result in a comfortable ride in an electric vehicle. Next, for our recommendation part, one of the ways we propose to enhance the torque ripple of the switch reluctance motor in this project is to employ a fuzzy logic current compensator (FLCC) to reduce torque ripples. The rotor position and reference current are the input of the Mamdani fuzzy controller, which produces the compensating current as an output. The second way we propose to reduce torque ripple in a switch reluctance motor is by using torque sharing function (TSF). TSF have been created as more effective and favorable way for reducing torque ripple in SRM. The efficiency and torque ripple of an SRM drive can be significantly increased by employing nonlinear TSF to adjust current in two neighboring phases during commutation. The torque sharing features can help to increase drive efficiency, expand the torque ripple free speed range, and reduce peak current requirement. That's all from our group. Thank you.